Hi, good day and welcome back to Everything Mathematics. So after the last video I did with the lattice method concept, one of my students told me that I should do more practice questions just for them to get it even better. So that's what today's video will focus on. So I will just strictly just come up with some random generic numbers to multiply, and I'll apply the lattice method. So let's see if we could just do 4 at least for starters, and see where we go from there. So let's call this example number 1. It's a pity this thing here doesn't have a forum in which you could just call out a random number and I just multiply. So I'm just coming up with random ones. And I so like to do math spontaneously. Like, I'm being quite honest with you when I tell you I don't have any preset questions. For most of my videos, I honestly just like to do it live. I just like to throw in something and figure it out as I go. And I think when I do that, it helps me better in the sense that it could be more genuine. You know, if I honestly practice beforehand, I will be flawless. And sometimes I do want you to see the honesty of working out certain questions. Like in the last video, if you saw the last video, when I honestly multiplied 936 by 32, I mixed up the 2 with the 3. And trust me, if I do these questions beforehand, that would never happen because I would know exactly what I will get and what to expect. So again, I love doing it just direct. So let me come up with 2 numbers here now. So let's see. Suppose we're multiplying 287 by, let's say, 56. Okay, let's say 57. 57. So here we have a 3 by 2 digit. So we're multiplying a 3 digit by a 2 digit. And again, it's all about highlighting the lattice method. So remember, we need to know how many digits we are multiplying so we would know how to create our little rectangle or a table, if you want to call it that way. So here is 3 by 2. I'll do this one different. For all those that I did yesterday, I usually put a bigger number on top. But I just want to show you that it doesn't matter how you do it, so long as the columns and the tables correspond, your answer will not be affected. So I will put a bigger number on the side and the smaller number at the top, right? Or the number of digits. So this will be a 2 by 3. Just to show you, you need to see variation so that you understand. I can't just tell you all the time, you have to see it too, right? So here I'm putting the 2 digits up here, 57. And my 3 digits will go on the side here. So I will put my 2, my 8, and my 7 here. Remember, after you split this, you have to split each one in its center diagonally. You just draw diagonally on each quadrilateral there. Good. Good, and that's my setting up. My setting up is done, and then it's just a matter of multiplying. So remember, the 7 by the 2, the 5 by the 2, 7 by the 8, 5 by the 8, 7 by 7, 5 by 7. And then we just add along the diagonals. We add along the diagonals. So let's get started. So 3 times 2, I know that will be 14. And I'll do 5 times 2, I know that's 10. 7 times 8, I think that's 56. Yes, it will be 56 because I know 7 sevens are 49. So I just add 7 to 49, and that's 56. And then we have 5 times 8, I know that's 40. Good. Then 7 times 7, yes, that's 49. Just made reference to that. And 7 times 5, I know that's 35. I love the 5 time table. It was one of the first tables that I learned. It was really easy. Good. And here we finish with the multiplication. And then it's just a matter of just adding down the diagonals. So for the first diagonal, we just have 9. So I'll just put my 9 here. Then I'm adding this diagonal here, 6, 4, and 5. So 6 and 4 is 10, plus 5, that's 15. So I put my 5 here, and I just throw in my plus 1 somewhere in the other diagonal, right? Then I have 5 plus 1, that is 6. 6 plus 4, that is 10. 10 plus 3, that is 13. So I will put my 3 here. As a matter of fact, let me be a little more specific here. I usually like to put it by the column so that we don't mix up, right? So we have 9 here. Then I think I had 5 here. What did I just get here? 5 plus 1 is 6, 10, 1, 13. So I have 3 here. So I'm putting it down the diagonal. I will line them up after. Then we have 4 plus 1, that's 5. And then we have 1, that's 1. So at the ending of the day here, my answer is supposed to be 15,359. Lattice method multiplication. And again, in case you're wondering if you could use this for exams, I will say yes. Of course, if you're doing it in your exam, just show your working. Because usually when they ask you to show your working, that's what you do. When we show we working, our idea of showing our working is 287 multiplied by 57. And then this is the whole concept of showing our working. If we do it this way, if we do it as I like to call this method the traditional old school. That's what we were taught. But if we use the lattice method, that's all you have to do. Show that you use the lattice method. So draw up your triangle, I keep saying triangle. Draw up your rectangle, your square, whatever shape you will end up with based on how much digits you're multiplying, and show your maths. Do your maths. Good. So don't do this in a corner and then just pop up with this answer from the blues. No. Show your working. Draw up your table, split up each square, do your multiplication, do your addition, and then pop up your answer. Good. I would think if I'm correct in your work, if I'm being honest with you, I will give you full marks for this because you showed me how you multiply the 2 digits. Good. And once you do this, of course, you also show me that you did not use calculator. I mean, even if you use calculator, let me say to come up with 7 times 8, for instance, if you forgot that. I mean, that's cool. But by right, if you know your tables, you know that that would not have been an issue. So that was question 1. Let's see if we could come up with another generic question. Let's try a big number. Some people think big numbers are hard to multiply. The hardest possible big number that you could get, maybe 999 multiplied by 999. This might look difficult, right? It might look difficult, but trust me, when you're doing it with the lattice method, it is quite encouraging to multiply a number like this. Like honestly, it's like there's no sweat in it. All you know is 81 coming on across the line. Well, let's see. Oh, I think I draw my thing too small. It's supposed to be a 3 by 3. So yeah, trust me, this could be a nightmare if you're multiplying it in the traditional method. Like honestly, I'm telling you. But when you're using the lattice method, it's actually fun to multiply this number. Let's see what we get. I have no idea what I will get, but all I know, the process should not be hard. And then I have this. Probably some students, if they see some numbers like this, the first thing they would want to do is run for a calculator, right? But it's not difficult with the lattice method. It's not difficult the other method either, you know, but honestly, as I said, it's easy to get lost. It's easy to lose track. Once you multiply a 3 digit by a 3 digit, it's very easy to lose track, go down the line. So watch how easy the lattice method make this thing look. So 999 times 999. So we know 9 nines are 81. So right away, without even going through that, we know that every square will end up with 81. We know that for a fact. So let me just full up with 81. And be careful you don't write 18 instead. That could throw you off too. So be careful. All these numbers could look tricky. So yeah, I safely put 81 right through because anyway you twist and turn it, 9 times 9 is 81. 9 times 9 is 81. 9 times 9 is 81. So see this made the multiplication process look a lot easier. Like right there and there, believe it or not, we finished with the multiplication. Now we're going to do the addition. And of course, if you have problems with addition, well, that's a different story. But we done multiplying here. Let's see what we get now. We're going to add now. And remember, we added down the diagonal. So here we have 1, so just 1. Here we have 8 plus 1 plus 1. So that's 8 plus 2, so that's 10. So I put 0 here, and I put my plus 1 in the next row. And it's not hard. Like, honestly, look at this. This making these big numbers look so easy. Like, so easy. I don't know if I'm too excited for this. So here we have 8 plus 1, that's 9, plus 1, that is 10, plus 8, that is 18, plus 1, that is 19. So I'm putting 9 here, and I just throw in my plus 1 somewhere in the next row. And let's go again. So here, look at what I have. I have 8 plus 2, that's 10, plus 8, that's 18, plus 1, that's 19, plus 8, that's 27. That's 27 there, and notice 27, so I have to add 2 here now. So you see, it wouldn't always be 1. It's based on how you add. So 2 and not 1 because it's 27. So we put the 7 and we add the 2 on the next row or column, or call it a diagonal. So 8 plus 2, that is 10. 10 plus 1, that is 13. And 13 plus 8, that is what? 21? 21. Okay, let me take a different route here just to be safe. Oh no. 8 plus 8 is 16. 16 plus 2 is 18 plus 1. Look at that. So I was almost passing oh, I see the mistake I make. I said 8 plus 2 is 10, which is true. But plus 1 now it will be 11 and not 13. I think I said 13. So yeah, this is 19. This is 19. So when I add that, I get 19. And then I add plus 1 here, and that will give me 9. 8 plus 1 is 9. So it is a big number. So the answer here will be 997, 901. Look at that. Like, honestly, because I'm explaining it, I probably took a little while. And I cannot see the timer here, but I am pretty sure I could do this in less than 1 minute. Like, honestly, I could do this in less than 1 minute. If I'm not talking and I just maybe, well, maybe more than a little minute, because it will take a little while maybe to come up with this table. But I mean, if I do a busy sketch thing, look at that. I quickly came up with 997,901 using the lattice method. I could bet you anything. If you do this the other method or the other way, you'd have probably be by the second row trying to sort out if you're under the right line or if you line up correctly. Probably you didn't reach the third row yet. But there you go. Lattice method. Pros of lattice method. It helps you to multiply faster. Well, again, as I said, granted that you know your tables. Granted that you know your tables. And I use 9 because I said 9 is the highest possible single digit that you could find that might be difficult. If you multiply by the tens, it doesn't matter because then the tens will become a 1 and a 0. Each one will have their own column. So you don't need to know those beyond there. Good. Let's go to the third example. I don't know, let's do a 4 by 2. A 4 by 2. So let's try 9, 8, 7, 9. And I'm trying to think of the highest number because those are the ones I assume would pose a problem, right? And then let's try that multiplied by, let's say 65. Multiplying by 65 is easy. Multiplying by 5 is easy. But yeah, let's try that. So we have a 4 digit by 2 digits. So my table here would look like a 4 by 3. I'll put the 4 at the top now. Right? No, not 4 by 3, sorry, 4 by 2. So 2 this way, and I need 4 here. So 1, 2, 3, 4, right? Because 4 digits. And I split each one of them in the middle. I split them with a diagonal. Good. So again, it takes a little while to set up, but like as I said, when you're versed with this, trust me, this is a walk in the park. So my 4-digit number will go here, 9, 8, a column each, 9, and 67, that will go here, 60, not 67, 65, good. And let's go and solve now. So here we need to know our tables. So 9 times 6, I think from earlier, we got that is 48. 7 times 6, I think that's 42. Well, of course, the only way you could get this wrong is if you don't know your tables, or if you multiply bad, right? Oh, I make a mistake here already, you see? I make a mistake already. 9, 6 is not a 52, because I look at the 8. Thank God the 8 was there, otherwise I made a mistake. 9, 6 are 54, 54, sorry. Is 8, 6 are 48. Thank God the 8 was there, otherwise I'd probably lose that one there. And 9, 6, same thing again, that will be 54, right? Yes. The 9 tables, yes, tend to pose a problem. 7 sometimes, 8, well, the higher order tables I would say. 9 5s, that's 45, because I know 9 8s are 40. 7 5s, that's a 35. 8 5s, that's a 40, just called you. And 9 5s, 45 again. So there you go. Multiplication, finito, c'est fini. That's in French, it's finished. So now let's go adding now. We add in rows, 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 rows. So 5 is by itself here, so we end up with 5 here. This is 4 plus 4, or how is it part to take from here? Okay, 5 plus 4, that's 9. 9 plus 4, that's 13. So that's 13. So that's plus 1. And then we have 6 plus 2, that's 8, and 8 plus 3, that's 11. So that's 11, 1. And we have 1, of course, from the other one, 11. Then let's see how we add in here. What's 2 numbers I could add here quickly? Oh, yes, good. I see 2 numbers I could add here. So 4 plus 1 is 5. 5 and this 5 here will give me 10. 10 plus 8, that's 18. And 18 plus 2, 22. That's the easiest part I could have seen there. And I add 2 here now because I end up with 22. Oh, look at that. Here I end up with 11, so I add 1. Here I end up with 22 and I add 2. I hope you're not thinking because I add 2 here, I end up with 2 here. I hope you understand what's happening there. Good. Then we have, well, 4 3s are 12 plus 2 is 14. So we end up with 14 here and we add 1 here and that leaves us with 6. Oh, this answer is surprisingly big. Well, there is a 4-digit by a 2-digit. So the answer here, this will be our breaker there. So our answer here would be 642,000 135. And by the way, as I said, I am doing these questions here live. I just coming up with some random numbers and I'm solving them. If you have any doubts, of course, feel free to take your calculators, plug in these numbers and see if we will actually get this. This would also probably, hopefully, validate the lattice method for you. Because if you've never seen this before, trust me, I'm not sure why we haven't taught this to students as yet, because this is so fast, so efficient, and at the end of the day, it makes your life easier. Like, honestly, I am enthusiastic to do multiplication with this method, because to me, it's a lot easier and it's more fun. Oh, and mind you, I'm a maths teacher. This is what I teach students. So yeah, don't think I just know this and I don't teach it. Yes, I actually do bring this to the classroom. And oftentimes, students never seen this before. All they know is this long, exhaustive method of coming up with number under number. And this is so cool and fun. Anybody learns this is like, you don't have no issue. Well, should not have no issue. And let's try another one. Let's try our last one. Let's call it number 4. I don't know, which other number? Oh, I thought of something interesting. Decimals. Yes, decimals could work here too. Decimals could work here too. And just like when we multiply in the old way, it's like, okay, no, let me do. We haven't done no decimal. So what if we had, for example, let's say 39.5, and we want to multiply that by, let's say, 4.3. Yes, thank God this came through my mind, and I never thought about this. Yes, so if we multiply in decimals, some of you might be thinking, but no, decimals cannot work with the lattice method. Yes, it could. It's just like when you're doing regular multiplication. Do you remember when you're doing regular multiplication, you're literally told to ignore the point? And that's what we do. We ignore the point. So technically, you have to see this as a 3-digit number multiplied by a 2-digit number. And then when you finish, then you count the number of decimal places. In this case, we're dealing with 2 decimal places, one from this side and one from this side. When we get our answer, we just count 2 places from our right. That's all there is to it. So yes, even if you're dealing with a decimal, it will work. So let's show you, or let's do this one. We're going to wrap up with this one. So again, all you have to see here is a 3 by 2. A 3 by 2. Yep. I'm glad this thought came to mind. I didn't even think about this in the planning process. And see again the beauty of doing some of these questions live. If I had planned this, or if I was sticking to a script, that would never come out. Well, maybe somebody that brought it up in the comment section. So 39.2, even though this is really and truly a 2-digit whole number, you have to see it as a 3-digit number overall. So we put in the 3, the 9, and the 5. If you want, you could put your point here, you know. You could. It doesn't change anything because it's not like you're multiplying point by point. But you could put it as a reminder that you have a decimal. And again, your 4.3 will be 4 and 3. And likewise, as I said, you could put your point here as a reminder that you're multiplying with a decimal, if you so wish. In fact, to be honest, I've never seen it like that. But I'm that confident and comfortable to tell you that it doesn't change anything. That's a fact. It doesn't change anything. It will not change anything. And now we multiply. Ignore the point. Just imagine the point is not there. So 5 times 4, that is 20. Good. 9 times 4, that is 36. 3 times 4, that is 12. 5 times 3, that is 15. 9 times 3, that is 27. And 3 times 3, that is 9. 0, 9. Ooh, multiplication process finished. Now addition. 5 just stays as 5. 7 plus 1, that is 8. 6 plus, what is it? Okay, so this is 19. 6 plus 2 plus 2, that's 4, so that's 10. 10 plus 9 is 19. So here we have 19, and I just throw in the plus 1 somewhere here. Here we have 2 plus 1, that's 3. 3 plus 3 is 6, so that's just 6, and 1 is just 1. So this answer here now is equal to, let me just write the digits, 169.85. Why do I put the point here? Because notice we have 2 decimal places. We have 1 decimal place here. We have 1 decimal place here. So basically, we just take the point just as we would have done when we're doing it the traditional way, and we just count 1, 2. So the point would have fallen there. And that's all. So yes, even if you're dealing with numbers, even if you're dealing with decimals, you could use the lattice method. And I think even here, it shows you how easy it is to use this method. Because at the end of the day, I know with the other strategy, students often struggle with the point. In fact, if I'm being honest with you, in fact, like honestly, true thing, I've seen students do this. So if we multiply 39.5 times 4.3, I've seen students kept the point come down the line. Yeah, like honestly. And again, this I believe is a concept brought over from adding and subtracting. Because yes, when you add and you subtract numbers, yes, point stays on the point. That's a fact. Point on the point. But in multiplication, it's not so, right? It's not like that. So yes, so hopefully doing it in a lattice method way, you will be encouraged and realize, oh my goodness, why didn't I learn this earlier? So please try this method, apply it. Trust me, I'm telling you as a maths teacher, this is the easiest way I've learned so far. There are other ways, but this is one of the easiest way I have learned so far to multiply numbers. And trust me, the bigger the digit, the easier it becomes because it's so encouraging. In fact, when to be honest, I don't even like to use this strategy when I'm multiplying small numbers. It's like I'm finishing too fast, you know? I'm finishing too fast. So, okay, I said this was the last example, but think about this. That's how quick it will be done. Imagine if I'm multiplying something like, let's say 284 times 3. It's like when I use the lattice method for this, it's like I'm finishing too fast. It's like I want more, you know? So it's like a 1 by 3. So 3. It's like you want a bigger number. You don't want to work with these little numbers. So you have 2, 8, 4, and then you have 3. I mean, of course, you could still do it, but as I said, you're finishing so fast. So here you have 12. Here you end up with 24. And here you will end up with 0.6. And like that's it. It's like you want more, you know? So this is 2. Here you end up with 5, and then you end up with 8. That's it. Like you're done. It's like, already, you know? So the lattice method, I think, promotes to me, for me, that is, it encourages multiplication of bigger numbers and multiple digits. The single digit ones, a matter of fact, you could have probably seen it. If you're good with multiplication, you could have probably seen this without even putting it here. But that's, yeah, it's too straightforward to use the lattice method. This is maybe where I will encourage the traditional method. Yeah, maybe when I'm doing something like this, I would prefer to do it this way. But I don't know, you make your pick. Which one was easier? Which one was easier? So when I do all my maths here, I should end up with 852 as well. But again, as I said, the lattice method, man, whew, they should teach this more in school. Primary school children should learn this. I think they will come in secondary school being experts of multiplication because there's no two numbers you could give them and they will start to shake. They'll just throw that on a lattice table and it's like, oh, now for now, I got this. So right, this will be the end of today's video. So again, as always, feel free to like, share, and subscribe if you haven't as yet. And until the next video, we're going to be looking at another unconventional method of operating fractions. Yes, and that is the butterfly method, a strategy you don't hear much about either. But we'll look at that maybe next video. So until then, you take care.